Welcome everyone. In this video, we're going to learn how to graph a quadratic function in turning point form. We already know what a turning point form of a quadratic looks like. So this can be written as the turning point form is y equals a x minus h the whole square plus k. Okay, so this turning point form can be obtained by for any quadratic function by using the completing the square technique which you learned before. Okay, so the beauty of this turning point form is it straight away gives you the turning point or the vertex, which then makes the graphing much easier. Also, this turning point form gives us the kind of transformations that has occurred to the simple quadratic function y equals a x square. So this turning point form is highly useful in that way. So now let's see how to use this turning point form to graph a quadratic function. Okay, so what are the different things that we require to plot a quadratic function? First thing, we need vertex or the turning point, which we can obtain directly from this turning point form, which is hk. And the second thing is the shape of the graph. Okay, shape. We know the shape of a quadratic function is parabola, but we want to know whether it's concave down or concave up. So an easy way to know that is if a is positive or if a is greater than 0, that means it is concave up. So it's a concave up. And if I is negative or less than 0, it's concave down. Okay, so that's easy to know from this turning point form as well. Okay, and then what are the different things we want to know? Okay, maybe x-intercepts and y-intercepts. Okay, once we know all these things, vertex, shape, x-intercepts and y-intercept, it's very straightforward to plot the function. Let's do one example. Y equals x plus 2 the whole square minus 1. Okay, first thing we want to know the vertex or turning point hk. So by comparing this with the standard form, we can see that h equals minus 2. So then only it will be minus of minus 2, that's the form, and k equals minus 1. Okay, so the vertex is minus 2 minus 1. Now, what is the shape? The a in this case is 1. That's why we don't write it. The coefficient is 1. And it's a positive number. So a is greater than 0. So the shape is concave up. Okay, now we need the x-intercepts and y-intercepts. So x-intercepts are the solutions of the equation x plus 2 the whole square minus 1 equals 0, or the values of x when y equals 0, the points at which the graph is cutting the x-axis. Okay, and so this can be solved to get x plus 2 the whole square. So we just need a simple algebraic manipulation. X plus 2 the whole square equals 1. And x plus 2 equals plus or minus 1. So, or x equals plus or minus 1 minus 2. So, the two x-intercepts are plus 1 minus 2, which is minus 1, and minus 1 minus 2 is minus 3. So, these are the two x-intercepts. So now we need to find the y-intercepts. That's the value of y when x equals 0, or the points where it cuts the y-axis. Okay, to find the y-intercepts, you need to put x equals 0 into this equation. So that's 2 square minus 1, which is 4 minus 1 equals 3. Okay, let's now plot the function. So first we need to mark vertex minus 2 minus 1, so that's the point here. Okay, so that's minus 2 minus 1, that's a turning point. And the shape is concave up, so the shape is like that. So the other points we require as x-intercepts, and those are minus 1 and minus 3. So it's a minus 1 is one x-intercept and minus 3 is another x-intercept. And y-intercept is 3. So this is 3. Now we need to plot the graph just by connecting these points. maintaining the shape. Okay, so that's how it looks like. So basically what we have done is we determined the vertex and determined the shape by looking at the sign of I. Okay, in this case it's concave up, and then we found the x-intercepts and y-intercepts and then drawn a parabola connecting these points. Let's do one more example. Y equals x minus 1 the whole square. Plot the function. The first thing we need is the vertex. So the vertex is given by hk. So comparing these equations, we get h as 1 and k as 0. So let's put that vertex into the graph. It's a 1, 0, so that's this one. Okay. Now let's find the shape. So that's given by the sign of I. A in this case is positive 1. So which means its I is greater than 0. The shape is concave up. Okay. So the shape is going like that. Concave up. Okay. Now we need x-intercept, maybe, and y-intercept. Okay, we need to think whether we need to find x-intercepts in this case. The graph is going like that. This means there's no other point. This graph is going to cut the x-axis. So this itself is the x-intercept because the turning point is already on the x-axis. So the solution of this equation x minus 1 the whole square equals 0 is x equals 1. So that's the only point it is cutting the x-axis. So we don't have to find the x-intercept in this case. The turning point itself is the x-intercept. Now we need to get the y-intercept. Y-intercept is obtained when you put x equals 0 in this equation. So y equals 0 minus 1 square. It's minus 1 square is 1. So that's 0, 1. So that's another point. So the graph is going like that. It's very simple way of plotting the function. Okay, so that's a graph. Okay, let's do one more example. Y equals x minus 1 the whole square plus 1. Plot this quadratic. First thing, we need to get the vertex. Vertex is obtained from hk. And comparing these equations, h is 1 and k is 1 as well. Okay, so let's put that one in here. So vertex is this one. So now we need to find whether the shape is concave down or concave up. Okay. The coefficient of x minus 1 the whole square, I, is actually plus 1 in here, which means it is concave up. So concave up. And then the graph is going concave up from here. Okay. Now we need to find x-intercept and y-intercept. Sometimes we don't have to find those. Let's see. X-intercept. Is there any point this graph is cutting the x-axis if the graph is concave up and the turning point is here? No. What does it mean? This doesn't have any real solutions. If the equation, for the equation x minus 1 the whole square plus 1 equals 0, there's no real solution. Okay, there's only complex solution, that's why it doesn't cut the x-axis. So there's no x-intercept. Now let's find the y-intercept. That's when x equals 0. Y equals 0 minus 1 the whole square, which is minus 1 the whole square plus 1. So which is 1 plus 1 equals 2. So the y-intercept is 0, 2. So that's the y-intercept. And the turning point was 1, 1. So now it's all about plotting this function, joining the points available. So that's something like that. Okay, so that's the function. Okay, so I hope this makes sense to you. So to plot the function using the turning point form is quite straightforward because the function straight away gives us the vertex and we can determine the shape quite easily by the sign of I. Okay, and then we need to find the x-intercepts and y-intercept if there are any. Okay.